Now we're going to do a little bit of addition of ordinates, which is, I've been talking about that. That's basically just a graphical technique where you add y values up for a particular value of x. This helps us to work out what a graphical version of f plus g of x might look like. Yeah? So it refers to the graph sketching, yes, of f plus g of x, which is f of x plus g of x. For a given value of x, we add the respective y values of f and g to get a sum, this baby here. Yeah? See? It's pretty easy. The ordinates, by the way, I've been saying, in case you haven't quite got it, are the y values. Ordinates are y values, and they're added together for a given value of x. Yeah? That's what happens. Okay, example 2. Sketch the graphs of f of x is x plus 2, g of x is minus x plus 3, and hence sketch the graph of f plus g of x. Alright, this looks pretty easy. Let's go for it. There's a table of values. I've got these values here. Now, that is the value of f of x for each of those values of x. x plus 2. You're just adding 2 to each of those x values. Looks right, doesn't it? Yeah? And g of x is minus x plus 3. So if you work that out, yeah, minus x would be plus 2, then add 3 is 5. Yeah, that looks okay, yeah? Now, the amazing thing here, ladies and gentlemen, is when you add up f of x to g of x, you always get 5. How amazing is that? Yes. Well, strange but true. So, here we go. We're going to draw f of x. That's f of x, isn't it? Looks right, doesn't it? Great. Looks like g of x there. That also looks right. It's got a gradient of minus 1 and y-intercept of plus 3. I'm happy with that. Now, what we're doing now is we're adding up. Now, adding up each of these respective y values which belongs to a particular x value, and we're getting the sum. Gets you the orange line. Okay, so you can see for x is minus 2, we're adding up a 0 value of y to a value on this purpley graph of 5, and 0 plus 5 is 5. Do you see? Yeah, you do, don't you? So here's another one. Look, on the y-axis, the green graph has a y-intercept of 2. The purple graph has a y-intercept of 3. 2 plus 3 is 5. See, it's working like a charm, yeah? Working like a charm. Sometimes you might not even do the table of values. You might just do it from the two sketch graphs and add the values of y up for specific values of x. Okay? That's what's called addition of ordinates. Are you happy with that? Good. NB, we can check the accuracy of our graph by finding its rule. Well, yes, we can. In this instance, we can, and it's very intuitive. So it's x plus 2 plus 3 minus x, and the x's cancel out, and you get 5. Well, that's why we've got all these 5s here. Funny about that. But you get it, don't you? Yeah, that's marvellous. So our sketch looks correct. It certainly does. Okay, example 3. Sketch the graph of f times g of x, where f of x is root x and g of x is x squared. Now guys, this is not really an addition of ordinates. It's really there. You can see that we're multiplying. Okay, we're not adding, so it's not an addition of ordinates question. But there is a reason why I've put this question in here, and that is basically the little trick to these things. This guy here is a fussy. Okay, he only works on 0 and positive x values, doesn't he? So therefore, if we're going to do this f times g of x, we've got to bear in mind that the domain of f times g of x will really be the intersection of this domain and this domain. See, that's the kicker. That's the kicker, guys. Yes? So, I've just written that there, okay? I've written that there, and therefore that is going to be the domain of f times g, okay? Because that's the intersection of the domain of this and the domain of that. Do you agree? Alright, so as long as we've got that straight, we're on safe ground. Otherwise, we're a little bit up the creek. So, f times g of x is root x times x squared, which is going to be now, how do you work that out? Come on, you know how to do that. That's x to the half, isn't it? Yeah? So therefore we get x to the half times x squared, and by your index laws that gets you x to the 5 over 2 or 2.5, yeah? Now it's a very weird kind of function, but it's just going to be a little bit steeper and more intense than x to the 2, because that's x to the 2.5, yeah? So it's going to be the same sort of shape, but just a bit more intense. So let's pick a couple of values and see if we can work out what's going on. When x is 4, if you work that out, square root of 4 is 2, 2 to the 5 is 32. Yes, good. Now when x is 9, it's getting really crazy. I've picked 9 because it's got a nice even square root, being 3, and 3 to the 5 is 243. This is a very crazy function, but let's look what it looks like. So therefore, I've put a few points in there, the ones we just worked out, plus 0. Okay, there's when x is 0, y will be 0. When x is 4, y will be 32. When x is 9, y will be 243. So you can see it's a wild function, yeah? Living on the wild side here, but that's what it looks like. And is that what we had to do? Let's see. Sketch the graph of f times g of x. And yes, so we've done it, but do you notice that I've only got the domain from 0 up? That is the kicker, okay? That's what you've got to bear in mind for these functions. All right, I think I've said it enough now. And are you happy? Great. All right, I'll see you soon.